Hello, my name is Thomas Gandrud. I am studying electrical engineering in the College of Science and Engineering at the University of Minnesota, Twin Cities. I'm currently enrolled in EE 1301, a class instructed by Professor Faisal Kaleem. As an electrical engineer, someday I would hope to create better methods of obtaining renewable energy, or just methods to improve the transportation of that energy. And EE 1301 has given me some of the background I need to begin my education as an electrical engineer, and also a really good knowledge of the C programming language that I think will probably be very useful to me and really interesting, actually, because I've never programmed before. But yeah, so it's really interesting. But today I want to talk to you about a project I made using an Arduino microcontroller. It is the photo-operated alarm clock. It basically uses a photoresistor to detect intensity of light, and based on that intensity, it will, if it reaches a certain point, it'll set off the alarm that can wake you up in the morning. Instead of relying on the time, you can just rise with the sun, because as Benjamin Franklin said, early to bed, early to rise makes a man healthy, wealthy, and wise. So, sometimes it's good not to sleep in past noon on weekdays. But anyway, I'm going to talk a little bit about the circuit diagram first for the setup, and then we'll show the setup, maybe put it together a little bit. So yeah, here we go. So here we have the circuit for the photoresistor on the alarm clock. We start here with the 5 volts supplied by the Arduino, go past these 3 resistors in series. They're each 1500 ohms, so that gives us the total 4500 ohms, past the photoresistor, and then through the ground. Between these two is where the Arduino reads the current and knows whether or not enough sunlight is hitting the photoresistor to activate the alarm, because Ohm's law tells us that the voltage is equal to the current times the resistance. So if there's a lot of sunlight and the resistance of this goes down, then we're going to need the current to increase, because we have a constant 5 volts supplied. And that's basically how the Arduino will sense whether the alarm is to be activated, is whether the current is high or low enough, depending on how much light you're going to need. So basically that's all we need to know for now, and let's take a look at the circuit components. Alright, so before we look at the actual circuit, we also need to talk a little bit about the buzzer that we will be using to make the noise. So it's a piezo buzzer, and basically the Arduino sends a variable input here, and then the ground is obviously on that side. So what the buzzer does is it gets turned on and off really fast, which then makes the different frequencies of the sound wave that our ear perceives as different pitches. So by varying the times between on and off very quickly, it will then produce the pitch that will be able to give us song tones, or just wave the tone around to make you wake up easier, or whatever you need to do. So it's a really handy tool to have for an Arduino, because it can do so many different pitches for whatever it's needed to do. Yeah, so now let's look at the actual circuit. So here's the setup we have for the circuit. The 5 volt comes out of this white cord here, goes through these 3 resistors. This one is the photoresistor that senses the light, and then this red wire here is the input to the Arduino that reads how much current is going through here. Over here you have the buzzer that is just kind of on a circuit of its own. This one goes into the Arduino, and that will allow the Arduino to turn it on or off based on whether the alarm's going on there. So it's really a pretty simple circuit. So now we're going to do a test of the device. We're going to plug it in. Should have it set up so that nothing happens right now, but when I tilt it, it should work. And there we go. So that's basically the main alarm function. Next we'll go into another function I've prepared. Alright, so now if you want to have more of a melodic wake up, we can do this scaling C scale wake up. And that will repeat until you press this button. So yeah, and then we will take a look at the final one now. All right, and this is the final one. It is the song Bingo as a kid's song. Basically, you can do any song more or less because the buzzer can be set to certain frequencies that can play all the notes, but the pitch isn't really the greatest, so you can get the general idea, but we'll just see it here. So. Yeah, so there's that one. All right, so here we have the project code. As you can see, the first three here is just selecting the variables. We've got the buzzer pin, number 3. That's just the third pin spot on the analog side of the Arduino. So basically, any slot will work as long as you make sure that the numbers match. And the light valve, similarly, is on the analog side in the 0 slot. So as long as the pin slot in this match, then any of the analog slots will work. And then light valve is just a simple variable there. For the setup, we've got the buzzer as an output. And then the function that I have here, I initialized this serial input because it helps to, when you're trying to find out the light value that you want to get before the alarm sets off, it helps when the serial input prints the light values it's getting so that you can set up tests to determine what value you're going to want to set it for so that you don't wake up at the wrong time or something. Alright, so then we get to the loop, and yeah, so here I have first the light valve equals what the light pin is reading. That's just the current that's going through it, sort of in Arduino terms. The analog read is from 0 to 1023, so it's a number in there that corresponds to the current, but it's close enough for our approximations. And you can see here that mine is 240 was the value that I wanted to set as the boundary, so that if it was 240 or below, meaning that if there was enough light so that the resistance was low enough that I got 240, which means that most of the voltage would be dropping across the first 3 resistors, which is why that number gets lower if the sunlight increases. That is the number that I was using. And then I have these 3 functions here. The buzz function is just the simple alarm that I made. The scale is the C scale, and then bingo plays the bingo song. You see here by just commenting things out or doing things like that, you can just select which one you want to hear. So we'll just go through them. The buzz function we've got here, it basically, most of these are just based on these for loops that go through. The 80 here is just the amount of times to determine the length of the buzz for each time, and then the tone cue here is the important part. It kind of sets the pseudo frequency between the highs and lows of the buzzer, and that gives you the pitch that you want to hear. So the tone cue here is just for the buzzer, since it's only one pitch at this point, it doesn't really matter. You can just use this blanket value of tone cue. And then this delay just makes sure that the pitches don't overlap one another so it doesn't get crazy and everything. But yeah, this one's pretty simple. It just 50 times, you see here, the code just basically runs through this for loop here 50 times. And then at the end of each of those loops, yeah, at the end, okay, yeah, so at the end of each of those loops, the delay function here, it subtracts 10 from the delay, which will it'll decrease the delay between the buzzes, which will make them just more frequent. Yeah, so that happens until the delay value is less than 20, in which case it will then subtract 10 from the tone to make the tone higher, and that's when it like swoops up and goes to a really high pitch, so that hopefully if you're not awake, you'll wake up when there's a really loud pitch going on. And then you see that I have the while tone cue. Oh, that's for this one. Actually, you just subtract the 10 here, as long as it's going. Then this do while loop here just pretty much says play this over and over while 1 is equal to 1, which is always true, so it's just going to continually do it until you reset the alarm. So that's how that one works. Basically, the delay microseconds is just, we don't want the regular delay because delay is milliseconds, and the frequencies for the pitch require lower time intervals, so that's why we use delay microseconds. And then, yep, just writing the buzz pin there. So, and the C major scale, basically the same. I have these delays here, but I had separate delays, and they're kind of arbitrary. And then these are the tones for each of the pitches that we'll be using, where X is just the counting variable again. But yeah, so this first tone is the low C. This one's the E, the G, and then the high C. So that'll make the 1, 3, 5, 8 chord that we're going to be making here. So then you see that it runs through 3 times this, where the first cue we've got here, it does this, which is just the tone 1, so that's the C. It goes through the C 3 times, then it goes down here and does the E 3 times. Then it keeps going and does the G 3 times. And then the first time it goes through C will be less than 2. So then it'll just go down to the E again here. E. And then else if, so then it'll just go back up and do this again. And then it'll do that again. And the third time when C is 2, it goes C, E, G, and then C is equal to 2. So then it goes C, E, G, C, high C, then back to G, back down to E, and then it starts over. By using the do loop again, I have the while here that's 1 equal to 1, which is always true, so it'll just keep going through this whole thing and looping the entire time. And the bingo code is equally simple. You just establish this int beat is just the time between, or the time for each of these 4 values, the length of each note, which is pretty arbitrary, but just sometimes if you want a half note, for example, instead of a quarter note, you just double the beat, so we'll see that later. And then we've got the notes here that are just ascending scale of all these frequencies, so we can just say first one is G, so it's going to be a G, and then it'll make the pin high and then low, so it'll just play a G, and then it'll do this delay so that the notes don't run into one another. That's what this delay is for. And then yeah, keeps going. We got the beat here, going. So basically you can do this with any song as long as you know the notes for it. Obviously it won't be super great, but I mean it'll work, whatever you want to wake up to. And then here is where we have a half note. See, we want to double the length of the note, so that's where that beat times 2 comes in, and then this delay is for rests, where the symbol just do nothing for the beat. So, and that's about all there is to this code here. It just keeps going all the way through the song. And then again, the while loop. That's always true, so it'll just keep playing over and over again. And yeah, so it's really simple to add your own thing, different songs. You just comment this out, add a new thing like my song or something, and then you would just go down here, void, because we don't want to return anything probably, my song, boom, just, and then go type away, make a function, and then it'll play it for you. So whatever song you want to wake up to. But that is the gist of the code. So yeah. So that's basically all there is to the photo alarm clock. Thank you for watching, and I hope you'll implement this in the future.